All right, hello everybody. We're going to talk about free fall today. I'm going to do the 3 experiments that were in your packet and talk about the different scenarios. So first of all, it said to drop a shoe compared to a horizontally held piece of paper. So, got a shoe here and a piece of paper. So we'll go ahead and drop those at the same time. And you can see the shoe falls much more quickly. All right. Now, if we hold the piece of paper vertically, I'm just going to put a slight little crease into it so it'll fall a little more straight. So hold it vertically, and you can see that it falls at the same rate. Okay, so I'll repeat that for you one more time. And so they both fall at the same rate. And so that's pretty astounding because the shoe is probably 100 times heavier, has 100 times larger force of gravity acting on it. All right. And then finally, if you couldn't get the last one to work, I bet you can get this one to work, which is to take a piece of paper, crumple it up, and drop it at the same time as the shoe, and see that they fall at the same rate. All right. Now, let's just talk about free fall a little bit more. First of all, in your book, it says that the most remarkable and unexpected fact about falling objects is that if air resistance and friction are negligible, then in a given location, all objects fall toward the center of the Earth with the same constant acceleration independent of their mass. And that's what we were just seeing, that the shoe and the piece of paper would fall at the same rate if air resistance was insignificant. Okay? Their definition of free fall says that air resistance has to be 0. Now, I don't think that's the best way for us to think of it. I think if we just say that if air resistance is negligible, then something is in free fall. But we certainly are close enough to free fall in what we just saw, and we did not have 0 air resistance. The shoe and the crumpled piece of paper and the vertically held piece of paper all fell at the same rate, even though there was air resistance present. I am here breathing, so there must be air resistance, and yet all of those objects were falling at the same rate. They had an acceleration of 9.8 meters per second. So each second that went by, they were speeding up at that same rate, which means they were getting faster and faster and faster. All right, now let's think about those scenarios that are down at the end of the free fall concepts page. It says, which of the following objects are in free fall? And I'm going to start right there with a rock thrown at a 45-degree angle at 6 miles per hour just after release. So if the person has let go of it, their hand is no longer exerting a force on it, and so the only force acting on it is the force of gravity. So yes, that is in free fall. A rock held stationary on the moon. Well, if the person is holding it, then they're exerting a force on it, so it's not in free fall. Case C, a feather after falling 30 feet but not yet in contact with the ground. Since it doesn't say where this is happening, assume it to be happening on Earth. If it's a feather and it's fallen 30 feet, it's going to have significant air resistance, so it's not in free fall. D, a feather after falling 300 feet in a vacuum. So that could either be on the moon or in a vacuum chamber, and they do have gigantic vacuum chambers. Check out YouTube and find videos of a hammer and feather or a bowling ball and feather in a vacuum chamber. Really cool videos. And so if there's no air there's no air resistance. And so yes, D, that object is in free fall. A paper ball after falling 3 feet on Earth, but it's not yet in contact with the ground. We saw it falls at the same rate as the shoe. So yes, that would be a case of free fall. A baseball thrown straight upward at 3 meters per second. So you're throwing it up. It's left your hand. It's going upward. But what forces are acting on it? Just the force of gravity. And so yes, that object is in free fall. So as we saw in case A, where the object was going at an angle, or case F, where the object was going up, it doesn't matter what direction the object is going for it to be considered to be in free fall. All right, so again, case A, yes. B, no. C, no. D, yes. E, yes. F, yes. All of those last ones in free fall. All right, I hope that makes things a little bit more clear for the concept of free fall.